third and final example. This is a very practical example of optimizing the parking of cars so that jockey time is minimized. On this screen you'll be able to see, a little bit small, but you can see two of the parking rules in play. One is called the model is Beetle, the Volkswagen Beetle, and another is the port of delivery is Germany. Place of delivery is Germany. Users apply these rules to their yard when they design it. So they may designate NL, for example, to be for Netherlands deliveries, and within that area NL in the yard, rows 1 to 4 could be set aside for the Beetle model. So these rules now act like a magnet. So when a user or workflow wants to ask the question, where can I park this car or cars, the answer can be instantly computed by the algorithm. So the yard has been set up with parking rules. This screen is showing 10 cars which have just arrived by ship. There are 2 Beetles in the list. The parking optimization is usually automatic actually, but to show this we can see a simple menu here where we are asking the system to help us plan the best location. This screen shows that 10 yard movements have been planned to the best location. And those moves are instantly pushed out to the yard supervisors for distribution to jockeys, or more usually, they are auto-allocated to the best position jockey and pushed to a mobile, rugged, handheld computer. This screen confirms a precise planned slot or general zone where the cars should be parked. This screen shows the managers the hourly workload in the yard caused by those moves. This list is simply split by hour, 11 o'clock and 12 o'clock. It can show us the number of moves per hour, the distance to move the cars, and the calculated time for all the moves. Note that the time is not in direct proportion to the distance. Why? Well, that's because the system also knows of other tasks which the jockey may have to do for that move. He may have to refuel the car, or do some extra quality checks, or he may be passing along speed-restricted roadways. And finally, this screen explodes the data from the previous screen to show the details of each car. It could just as easily show the jockey who is moving the car or the bus crew assigned. And all this is part of the configuration toolkit that we use. So I mentioned jockeys and giving them work to do and planning and so on, but these people are vital in the process, and it's vital because they give us feedback that they have done the work that was required of them. And Vehnet can use a rich set of technology here. You can use mobile phones, rugged scanners, passive or active RFID, and we're currently looking at multi-language voice recognition over the radio. So it's all very interesting. Here are some screenshots from our mobile suite, which is part of the Yard solution. Very nice and easy screens, including the kind of sign-on screens and online and offline capability, and it's all available on industry standard equipment. It's quite interesting, I think, that even when RFID is installed, and that does give you your location, you still need to invest in mobile equipment because you still need to push information out to the people in the yard who are doing the work. So that's just a practical point. So the benefits of leaner yards would include reduced jockey time, better labour forecast, so you can buy labour better and not waste it, smarter put-away rules which give lots of benefits of damage and so on, and there's a lot more as well which I think people will appreciate.